Hey guys, we're going to be looking at linear inequalities in two variables. So as you walk in, you'll see that as the lesson of the day. Okay. So just a couple of notes that are going to be very important. Okay. Anytime you see greater than or less than, okay, but not equal to, you're going to be using dashed lines. This may not make sense completely right now, but it will in a bit. And if you have the same signs but equal to, you'll have an equivalent line but solid. Okay. So not equal to, how do you represent that on a line? Dashed lines equal to a solid line. Okay, it kind of makes sense, right? So this is a line that's there but do not include it. There's a line and include it. Alright, we'll be looking at two examples. So let's go and do that. Alright. So graph the inequality y is greater than 3/4 x minus 2. Okay. Well, let's go and find the easiest way to do this. Okay. Now, this is essentially, okay, I'm going to put this in quotations because it's not written like this, but I can interpret it like this to my advantage. Okay, y equals mx plus b. You guys know this to be your y-intercept. So I'll go ahead and jot it down like this. Now from there you guys know this to be your slope. Okay, so rise 3, run 4, right? A couple lines going here. So from here I'm supposed to rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4. So now I have 2 points, and just like it takes 2 points to compute the slope, I have 2 points to draw the slope. Okay. Now notice what I've done here is I've got a solid line, so I must check the notes you just received a second ago, and I notice there's not equal to. So I must come back here and I must indicate it's a dashed line. Okay. So I've broken it up for that purpose. And other than that, I have graphed the linear inequality, okay, at least the line itself. But this inequality, what it means is it's the area, okay, above or below. In this case, it's all the y values above this expression. So simply I'll shade above. Okay. So my solution, people, is all the points in this area, okay, but not the points on the line like these two guys. Alright. Next, you're going to be looking at graphing these linear inequalities using intercepts. Okay, so here's basically what you do. We're going to look at the y-intercept and the x-intercept. Now, in case you have forgotten, okay, when it comes to the y-intercept, x is 0, and we saw that using tables. So the x-intercept is identified when the y-coordinate is 0. Okay. So that's going to be very valuable. That's going to play a role here. So now I'll simply take the inequality. 8y is greater than negative 32. Okay. And what I'm going to do here is, because I am looking for the y value, I do know that x is 0, which will give me the y-intercept. Okay. So let's go and do that. 16 times 0 plus 8y is greater than negative 32. That disappears. 8y is greater than negative 32. Okay, I divide by 8, and we have y is greater than negative 4. And so that it doesn't add to the confusion, here's one thing I'm going to encourage you guys to do, is just like in the last example, turn these into equal signs. Okay, so at this point, we notice that x is 0, y is 4, so I'm going to go and jot that down here. 0, negative 4 is my y-intercept. I'm going to follow the same procedure here to get the x-intercept. Okay. Once again, although it is an inequality, I'm going to continue by creating an equation. So 16x plus 8y equals negative 32. Here I know that y is 0, so I'll plug that in. 8 times 0 equals negative 32. That disappears. 16x equals negative 32. X is, by dividing 16 to both sides. And if I'm skipping steps and it doesn't make sense, just go ahead and ask questions tomorrow. Okay? So I'm going to go and list it here, my x-intercept. 0 is y, negative 2 is x, and I have my x-intercept. So now that I have these two, again, the instructions were to graph. Let's go ahead and use our intercepts to our advantage. Here's a graph. Get some dashes going here. I'm going to go and plot 0, negative 4. So 0, negative 4, 1, 2, 3, 4. Next I'm going to plot negative 2, 0. Negative 2, 0. Okay. And I can connect the line. Whoops. Now that I've done that, I'm going to go and ask myself, okay, is the symbol here equal to? No, it's not. That means something to me. And if I look back at my notes, it means that I cannot have a solid line. Okay. So I'm going to break it up as such. And the next thing is how should I shade this is the next question. Okay, so apparently I haven't been given any other information to work with, so we're going to have to get clever here. Okay. Now we have a couple of options, right? We have this region and we have this region. So what I'm going to do here is I'm going to pick a point in the red region, specifically 0, 0, only because mathematically it's very convenient to do so. Okay, so let's go ahead and plug that in here. Alright, here it is. Okay, so basically what I'm proving here is if the solution is in this region, then 0, 0 should work. If it doesn't, then it cannot be this region. Okay. So I'm going to use 0, 0. Okay. So we got 16 times 0 plus 8 times 0 is greater than negative 32. 0 is greater than negative 32, and the answer to that is yes, it is. It's true. So that means 0, 0 falls in this red region and is therefore the region that I will be selecting as the solution to this inequality. Thank you for your time.